in a quiet corner of the Harvard College Observatory at the turn of the 20th century. A woman sat beneath dim yellow lamplight, her eyes fixed on a small square of glass. On it, thousands of tiny white dots shimmered faintly like frozen starlight. But to her, they were not just dots. They were voices. Whispers from across the universe singing a language only she seemed to understand. Henrietta Leavitt, a name unknown to most, leaned closer, magnifying glass trembling slightly in her hand. Around her, the world of science was roaring into the modern age. Einstein would soon publish his theory of relativity. Marie Curie was breaking barriers in radioactivity. And yet, in this small, dimly lit room, one quiet woman was about to do something that would change how humanity measured the cosmos forever. But before we get lost among the stars, let me ask you this. Where are you watching from right now? Somewhere beneath city lights where the stars barely peek through. Or maybe a place where the sky still breathes, dark, vast, infinite. Drop it in the comments. I want to know. And while you're at it, if you believe stories like these, stories of forgotten minds who changed the world, deserve to be heard again, then take a second to like this video and subscribe. You won't just be supporting the channel. You'll be helping us keep their light alive. Now, let's go back to where it all began, before the fame, before the glory, before anyone even believed a woman could measure the universe. Henrietta was born in 1868 in Lancaster, Massachusetts, to a minister's family. Her life began quietly, and for most of it, it stayed that way. There were no grand voyages, no celebrity scientists knocking at her door, no academic applause. Just faith, persistence, and a mind that refused to stop asking questions. As a young woman, she attended Oberlin College and then Radcliffe, where she discovered her fascination with astronomy, the kind of passion that doesn't just spark, it consumes. She loved the stars, not for their beauty, but for their secrets. Yet, even with her degree, she couldn't simply walk into an observatory and say, "I want to work." Not in 1890, not as a woman. In those days, Harvard College Observatory had a system that sounded progressive for its time. Women were hired as computers. But don't let the name fool you. They weren't given telescopes or freedom. Their job was to calculate, to catalog, to do the detailed work male astronomers didn't want to. The women were the unseen engines of discovery, and Henrietta would soon become its most powerful one, under the direction of Edward Charles Pickering. Dozens of women filled the computing room, each examining photographic plates of the sky. Comparing the brightness and position of stars, these plates, black glass negatives coated in silver, captured the light of distant galaxies long before humans even understood what a galaxy was. Henrietta, soft-spoken and partially deaf from an illness in her 20s, found herself among these women. The room buzzed with the sound of scratching pencils and whispered calculations. Yet she worked in silence, always slower, always more meticulous than the rest. She didn't rush. Every flicker of light on those glass plates mattered. Each one had a story to tell, and Henrietta, more than anyone, wanted to listen. In 1908, she began studying a peculiar group of stars known as Cepheid variables, stars that rhythmically brightened and dimmed over time. At first, they seemed unremarkable, a flickering pattern that others had ignored. But Henrietta saw something deeper, a pulse, a heartbeat, a clue. As she compared hundreds of stars in the Magellanic Clouds, she noticed a stunning pattern. The brighter the star, the longer its period of variation. It was as if the stars were speaking in code, the length of their heartbeat revealing how luminous they truly were. And if you knew their true brightness, you could measure their distance. It sounds simple now, almost obvious, but back then, it was revolutionary. Henrietta had just discovered a cosmic ruler, a way to measure how far away stars and galaxies truly were. She didn't yet realize that what she had done would one day let us understand the size of the entire universe. She was quietly building the foundation for modern cosmology, but the world wasn't ready for her. When her findings were published, they were buried within the observatory's reports, signed not by her, but by the institution's director. Her work was noted, yes, but her name barely whispered. She wasn't allowed to speak at scientific conferences, nor was she recognized as the true author of her own discovery. She worked for 25 cents an hour, barely enough to live on, and yet she stayed. She stayed because the stars didn't discriminate. They didn't care who she was, what she earned, or whether her name appeared in print. They only cared that someone was listening. As the years passed, Henrietta's health began to fail. But she never stopped working. Every night, she went home with the glow of starlight still imprinted in her eyes. She believed that her life's work, her careful records, her measured stars, her handwritten tables would help others see what she could only imagine. She might never touch a telescope, but through her equations, she touched the infinite. Meanwhile, outside her quiet world, astronomy was evolving. Other scientists began to take her data and build upon it. But few gave her credit. Even when her discovery was later used by Edwin Hubble to prove the universe was expanding, her name was barely mentioned. She had laid the groundwork for understanding that galaxies were not just stars within our own Milky Way, but vast, separate universes stretching into infinity. Yet the glory went elsewhere. Henrietta Leavitt's story isn't one of tragedy, though. It's one of purpose. She wasn't forgotten because her work was unimportant. She was forgotten because she worked in silence. And silence rarely makes history loud enough to hear. But now, after more than a century, her voice echoes louder than ever. Every telescope that measures a distant galaxy, every chart that maps the expanding cosmos, every theory that begins with how far, all of it starts with her. With Henrietta, the deaf woman who measured the universe. If you've ever doubted that one person, just one, could change the course of science without ever being seen, remember her. Because she didn't just look at stars, she measured their song. She gave humanity a scale to understand infinity. And maybe, just maybe, she gave us something more. Proof that even in silence, brilliance can roar. When the stars spoke, Henrietta Leavitt listened. And somewhere between the quiet ticking of clocks and the scratch of her pencil, she found a rhythm older than time itself. The discovery of the Cepheid variable relationship wasn't just a piece of data. It was the key to unlocking the scale of the universe. But in that moment, she had no idea what she had truly found. Imagine it, a modest desk, a stack of glass plates, and a woman bent over them in silence, unknowingly laying the foundation for every cosmic distance we measure today. It's almost poetic that the map of infinity was first drawn by a woman surrounded by limits. Yet, as extraordinary as her discovery was, the world didn't stop to listen. The early 1900s were not kind to women in science. The computing room at Harvard was filled with brilliance, but that brilliance was confined. They were nicknamed Pickering's Women, a title that told you everything about ownership and nothing about achievement. These women cataloged hundreds of thousands of stars, mapped nebulae, and calculated variables that defined the universe. Yet their names rarely appeared on papers. They were data gatherers in a world that reserved theory and recognition for men. Still, Henrietta's work shone through. Her tables of luminosity and period correlation became indispensable to astronomers, even if few of them realized just how powerful her discovery was. It was Edward Pickering himself who published her results in 1912 under the observatory's name. In a few quiet sentences, he summarized a revolution. A remarkable relation between the brightness and period of Cepheid variables has been discovered by Miss Leavitt. That was it. One sentence in a report filled with numbers and charts. No fanfare, no ceremony. Just quiet acknowledgement buried within academic formality. But history has a strange way of unfolding. Years later, across the ocean in a small observatory near Copenhagen, a Danish astronomer named Ejnar Hertzsprung stumbled upon Henrietta's data. He realized that if her period luminosity relation could be calibrated, If one could assign absolute brightness to even a single star on her chart, then this relation could serve as a cosmic yardstick. It would let astronomers measure the distance two stars too far away for parallax, the only distance method known at the time. In simple terms, Henrietta had built the ruler that the universe was missing. Hertzsprung used her data to measure distances to the Magellanic Clouds and, for the first time, to estimate how far other galaxies were. Think about that. A woman in a dusty Harvard office, who had never peered through a telescope, had given the world the first practical way to measure the cosmos. Without realizing it, Henrietta had changed astronomy forever. Yet her name remained a footnote. At Harvard, her health continued to decline. Her partial deafness made communication difficult. Her modest salary barely covered her expenses. But there was something in her, something quiet but unbreakable. Even as her body weakened, her determination grew. Every morning, she would climb the narrow stairs to the observatory's computing room, settle into her chair, and begin again. Her notebooks filled with columns of figures, her handwriting neat, her logic flawless. She once wrote in her notes, "It is a pleasure to measure something of real use to humanity." There's something hauntingly beautiful about that line. She didn't measure for fame or fortune. She measured because she believed in the value of discovery itself, in the act of expanding human understanding, no matter who got the credit. The light from distant stars was billions of years old, and she was giving it meaning, one calculation at a time. But as her star began to fade, others began to shine, using her work. In 1924, 12 years after Henrietta's death, a young American astronomer named Edwin Hubble pointed the 100-inch Hooker telescope at a small patch of sky in the Andromeda Nebula, using Henrietta's Cepheid variables. He measured the distances and realized something extraordinary. Andromeda wasn't a nebula within our Milky Way. It was a separate galaxy altogether. And not just that, the universe was filled with them. It was vast, boundless, far larger than anyone had ever imagined. That moment, the confirmation that our universe extends far beyond the Milky Way, is celebrated as one of the greatest discoveries in science. Hubble's name became immortal. His work redefined humanity's place in the cosmos. But here's the truth. Hubble could not have done it without Henrietta. Her discovery, her precise measurements, her data, they were the foundation. The distance ladder that made his revolution possible was built by her hands. Yet when history was written, her name was left behind. Even so, there's something poetic about her invisibility. Henrietta's stars, her Cepheids, continued to pulse, sending out their message into eternity. Every flicker of light that an astronomer measured was, in a way, her voice still echoing through the void. She had given the cosmos a language, and even if the world ignored her, the stars never would. And that's the strange paradox of genius. Sometimes the most influential people in history are the ones we never see. They live their lives quietly, creating ripples that become tsunamis long after they're gone. Henrietta Leavitt was one of them. She didn't shout. She didn't demand recognition. She simply measured the universe, and in doing so, gave us our place within it. By the 1920s, the Harvard computers began to fade into obscurity. New technologies replaced manual calculations. Photography became more precise. Many of these women's contributions were forgotten, hidden behind the names of the men who built upon their work. But Henrietta's name, fragile, faint, flickering, refused to disappear entirely. In 1925, 4 years after her death, the Swedish mathematician Gijto Mittag-Leffler wrote to Harvard to inquire if she might be nominated for the Nobel Prize in Physics for her discovery. He didn't know she had already died. The Nobel Prize is not awarded posthumously. Her recognition slipped quietly through the cracks of time, like light fading into darkness. Yet, there's a haunting justice in how her legacy endures today. Every telescope that measures the distance to a galaxy from Hubble to James Webb still uses her law. Every discovery about the expansion of the universe still echoes her insight. Without Henrietta Leavitt, our cosmic map would be meaningless numbers, our galaxies just nameless blurs of light. She gave them scale. She gave them distance. She gave them identity. Imagine her now, not the frail woman hunched over glass plates, but the legacy she's become. Standing at the edge of the universe, surrounded by stars that pulse in perfect rhythm, each one singing her song. She may not have heard applause in life, but in death, the entire cosmos beats to her measure. Henrietta's story isn't just about science, it's about perspective. About how humanity often overlooks the quiet ones. Our discovery isn't always loud or dramatic. Sometimes it's found in the silence between breaths, in the patient observation of what others ignore. Her journey reminds us that brilliance doesn't need validation. Truth is its own reward. So as you listen to her story tonight, think about how many other forgotten minds there might be. People who measured something monumental, but were never measured themselves. If that thought stirs something in you, if you believe in shining a light on the unseen, giving voice to the unheard, then don't let this story end here. Leave a comment telling us what you think about Henrietta's legacy. Should we bring her name to every astronomy classroom, every science documentary, every student who gazes up at the night sky? Because the truth is, she's already there, written between the stars. And if you want to keep uncovering more stories like hers, tales of genius buried beneath history's silence, then make sure you subscribe to this channel and turn on the bell icon. Because in the next story, we'll explore another mind who, like Henrietta, changed the world before the world even knew their name. Trust me, you don't want to miss it. When Henrietta Leavitt closed her notebook for the last time, the world didn't notice. There were no headlines, no celebrations, no grand recognition. Just the soft ticking of the observatory clock and the whisper of time moving forward, carrying her discoveries into the hands of others. But even though she was gone, her stars continued to pulse, like living echoes of her mind scattered across the heavens. Years passed, and with them, a new generation of astronomers emerged, men who would become legends. They stood on mountaintops, built powerful telescopes, and gazed deeper into the cosmos than anyone before. Yet behind every number they calculated, every light curve they plotted, was Henrietta's rhythm, the period luminosity law she had so carefully mapped by hand. Her discovery had quietly rewritten the universe. Astronomers could now measure cosmic distances with precision. They could chart galaxies, understand their sizes, and even estimate the scale of the observable universe itself. Her work became the invisible framework upon which the greatest discoveries of the 20th century were built. But here's the tragedy and the beauty of it all. While her name faded from the pages of textbooks, her formula never did. The Leavitt Law, as it's known today, remains one of the cornerstones of astrophysics. It's been refined and remeasured, but never replaced. Every modern telescope, from Hubble to James Webb, still relies on it. Every time scientists talk about measuring the expansion of the universe, they're using her method. And yet, think about this. Henrietta never looked through a telescope herself. She never had access to the instruments that defined her field. Her eyes were fixed not on the night sky, but on glass photographic plates. Tiny frozen images of the universe, captured by others, measured by her. She found meaning where others saw noise. She gave life to dots of light. In a way, she represents something deeply human, the ability to find beauty and purpose in obscurity. While others sought glory and discovery, Henrietta sought truth. That's what makes her story so profound. She wasn't just measuring brightness, she was measuring the heartbeat of creation itself. Let's pause for a moment and imagine it visually. The early 1900s, a dimly lit Harvard Observatory. Rows of women hunched over desks, each illuminated by a small pool of lamplight. Dust floats in the air like drifting stardust. Henrietta sits quietly, tracing patterns between numbers and stars, her mind reaching farther than any telescope could. Outside, snow falls gently on the cobblestone paths, muffling the sounds of the world that docenti yet understand what's happening inside that room. Now, fast forward over a century later. A spacecraft drifts silently through space, the James Webb Space Telescope, capturing light from galaxies billions of light-years away. The faint pulse of a Cepheid variable star flickers in its sensors, and once again, astronomers use Henrietta's formula to calculate its distance. Her law still breathes, through metal and machinery, through data and light. It's as if she coded her heartbeat into the universe itself. And it's only now that we begin to truly grasp the scale of what she did. Her discovery didn't just help measure distances, it helped confirm the Big Bang, understand the universe's expansion, and even predict its age. Without her work, the cosmic story would still be missing its structure. But the irony remains. Her name is still largely unknown outside of scientific circles. No blockbuster movies, no global recognition, no monuments in her honor. Just quiet reverence among those who know. And perhaps that's fitting, because Henrietta's brilliance was never loud. It was constant, steady, and faithful, like the stars she studied. Still, in recent years, something extraordinary has happened. Historians and scientists have begun to rediscover her story. Books have been written, documentaries made, and slowly, her name is rising from the shadows, carried by those who believe that forgotten geniuses deserve their light. Henrietta's story forces us to ask an uncomfortable question. How many other names have been erased from history simply because they didn't fit the mold of who was supposed to be a scientist? How many groundbreaking discoveries have been attributed to others because the true discoverers were unseen, unheard, or uncredited? When you think about it, the night sky is full of such ghosts, stars whose light began its journey long before we were born, shining for millennia before we finally see it. Henrietta is one of them. Her light began in silence, but it's only now reaching us. And maybe that's the greatest metaphor of all. Her discovery was about light that takes years, centuries, even millennia to reach us. And her own recognition followed the same law, delayed but inevitable. Because truth, like starlight, can never stay hidden forever. Her life ended quietly in 1921. She was only 53. There were no awards, no tributes, no grand send-off. But now, over 100 years later, her work continues to shape the very science that defines our understanding of the cosmos. Every galaxy we photograph, every supernova we measure, every distance we calculate, all of it, in some way, traces back to Henrietta Leavitt. So the next time you look up at the night sky, when you see a star flicker faintly against the darkness, remember her. Remember that the universe we know, the distances we measure, the beauty we comprehend, all began with one woman and her unwavering faith in the power of numbers. Because Henrietta didn't just measure the universe, she gave it scale. She made infinity tangible. And in doing so, she proved that even the smallest, quietest voices can echo across eternity. If Henrietta Leavitt's story made you look at the stars a little differently, don't let her light fade again. Subscribe to Pioneers in the Dark and press the bell icon so you never miss another story of the forgotten minds who shaped our world, the dreamers, the thinkers, the outcasts, who changed science but were lost in its shadows. Out there, countless stories still wait to be found, just like Henrietta's stars. And together, we'll bring them back to light.